Alright guys, this is problem 19 or problem 20 of the AMC 10 test A, and this is one of the harder problems. Alright, so let's start reading it. It says a scanning code consists of a 7 by 7 grid of squares with some of its squared colored black and the rest colored white. There must be at least one square of each color in this grid of 49 squares. A scanning code is called symmetric if its look does not change when the entire square is rotated by a multiple of 90 degrees counterclockwise around its center, nor when it is reflected across a line joining opposite corners or a line joining midpoints of opposite sides. Whew, lots to take in. What is the total number of possible symmetric scanning codes? All right. So, you know, I don't. So when I first looked at this problem, I didn't know what to do. So when you don't know what to do, you draw a diagram. All right. So let's draw a diagram of a 7 by 7 grid of squares. So we're drawing it out. Alright, so we have one line going down, two lines going down, three. So we're just drawing it out. So how many of that's 1, 2, 3, 5, 6. And let's draw just another one right here. Squeeze it in. Alright, so yeah, oh my gosh, this is a very ugly 7 by 7 grid of squares. But alright, let's work with it, alright? So we have this middle piece right here, right? And so if we want, so it's telling us when we rotate this 7 by 7 grid of squares when we rotate it by 90, any multiple of 90 degrees, right? So 90, 180, 270, something like that. When we rotate it like that, we have to get the exact same coloring still, all right? And so we know that this middle piece right here, when either time we rotate it, it will always stay the same, right? The color, the coloring will not be distorted at all, okay? So let's add the letter A, all right? Just so A represents a color either black or white, and it has to be consistent with the other A's inside this grid, all right? And so what else do we know? We know that if we labeled B right here, right? B is just another color. B, 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 B. We would also have something symmetrical if we rotate it by a multiple of 90 degrees, right? Because let's imagine rotating something. Let's just take that little portion, right? If we have A right here, we have B right here. If we imagine rotating this, we would find that we would get the same exact coloring still, alright? So we have B's right there. We could also put C's right here. You might start to see a pattern with this little plus sign right here, alright? Let's add D right here. Alright, so we just added D right here. Now what else can we add, alright? Well, we can also add E right here, right? We can add an E right there. Alright, if you're getting a little stuck, just imagine yourself rotating a physical 7 by 7 grid of squares. Imagine yourself rotating that with arbitrary colors, right? E could be black or white, but it has to stay consistent with the other E's in here, alright? And so where else can we label? Well, we could label G, for example. We can label G. Let's try labeling G. So how do we label G? You have G right here. Put two G's up here. Put a G right here. Put a G right here and the small one. Alright, G right here. Alright, so we're just extending out this plus sign right here, right? So we have G's all the way out here. We can have F, right? We can have F. Let's put our F right here. Alright, we're just extending that little plus sign. We're making it a little bigger. Oh wait, where do we put F's? Yeah, we put F's right here. Oh, I'm trying to squeeze in that F. Alright, so just imagine yourself rotating it again, alright? I want you to picture in your mind. Close your eyes if you need to. Rotate the 7x7 grid, alright? And you'd see we still get the same thing. Alright, so we have that. We have F right there. What else can we do? We could put H right here. Right? We could put H. H is around. H, 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 H. I'll put H's right there. Do we need to put our H's anywhere else? So I'm just gonna imagine myself rotating it. So we rotate it. I don't think we need anywhere else for H, alright? So now let's try I now. Alright, let's try the letter I. So we would label our I's. Right, where should we label our I's? I right here. I right here. I right here. I right here. And do we need to label our I anywhere else? I think we're missing something right here. What are we missing? Oh, we're missing I right. Yeah, we need to label I right here as well. Alright, because I'm just going to imagine myself rotate it, and we see that we need I right there. And then the last letter right here, J. We put J right here. And so now you see, if we have this example grid right here, and we just labeled it with letters, right? These letters can be any color. I repeat, these letters can be any color, right? But it just has to stay consistent with the letter itself. Alright, so we can imagine ourselves rotating this by 90 degrees, 180 degrees, 270 degrees, and we still get the same exact figure with the same colors, okay? So we do that. And now we get into the meat of this problem, alright? So we know that we have two choices of color. We have black or we have white, alright? So if we have black or if we have white, that means these letters right here represent either of those two colors, right? And how many letters do we have right here? We have A, B, C, D, E, F, G, H, I, and then J, right? And that's 10 letters. That's 10 letters right there. So if we have two choices for our colors, we raise it to the 10th power because we have 10 letters. Alright, so 2 to the 10th power, what is that? Well, that is 1024. Alright, and so you might think you're set, right? I have 1024. Well, in the problem right here says there must be at least one square of each color. So that means this 1024, that's including our fully black square or fully white square, but it's telling us that's not allowed. So we're going to subtract 2 from 1024, and we get 1022. And guess what? 1022 happens to be one of our answers right here. And so B, if you don't know already, is the answer. And there you go. And so, I had trouble with this problem at first, but when you're having trouble, when you're stuck, when you're just clueless, don't know what to do, the best thing to do is draw a diagram, alright? That'll get you through all your problems.